When using this kind of stupid charge controller which overshoots the voltage if the battery is fully charged, it thinking the BMS disconnect the battery for a millisecond and it thinking the battery is disappear, so it overshoot the PV voltage into the battery terminal. That is the cause to damage the inverter. This is our inverter, the home, and here I show you that is happen to the MOSFET. Okay, they are using the CS105115N. This is a 40 volt 150 ampere MOSFET. That one is blown, and now I will upgrade this one with my own HY1906 that I use. It's a N channel MOSFET, 60 volt 120 ampere, very low RDS on, perfect choice for 12 volt 24 volt inverters. The gate component I no need to change because the gate component 10 ohm and 10k resistor for pull down is suitable for this MOSFET to HY1906P. If your inverter is good but the charge controller not good, it can damage your internal MOSFET because the over voltage spike can damage your DC side. This was a good inverter. The AC side is still working, no problem. I will also replace the original DC bus capacitor, which is 4700 UF 25 volt, and I will use 6800 UF 35 volt. It will help more stabilize the DC input side, and it will help from the preventing the charge controller over spike. All MOSFETs I take out ready. Now set your multimeter onto resistance mode and test all the gate to source resistor 10k. Check all one by one. 10k, 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 and 10k. That is the gate to source resistor is tested. Now we check the gate resistors. 10 ohm, 10 ohm, 10 ohm, 10 ohm. So gate to source is 10k and gate signal is 10 ohm. All resistor value must be all same. So all value should be same between gate to source resistance, that is called pull down resistor. It can be 10k. So that, and then gate signal resistor 10 ohm must be same. Now the second test, we will check the gate voltage. All the gate voltage we test. I power up ready, and now we will check the all gate voltage. 6.37, 1, 6.37, 2, 6.37, that was the blown MOSFET. 6.36, 6.36, okay, acceptable. 6.36, acceptable. And 6.367, acceptable. All voltage is good, so we one time more verify the blown MOSFET. Gate resistor 6.377. All the gate to source resistor and gate resistors are same. Gate voltage we just now test is same. Now it's time to test the frequency onto the all gates. Set your multimeter to frequency mode, and we test the frequency 29 kilohertz. Okay, all we test onto the all MOSFETs gate 29.45, correct. 29.43, correct. 29.43, correct. 29.44 correct, 43 correct, and 29.42 correct. So resistance check, the gate voltage is checked, and frequency is checked. Now it's time to install the MOSFETs. Now I will clean the heat sink. We are ready to install our new HY1906 MOSFET, my favorite. This is the final test between drain to source on diode mode. All test, all the reading must be same. So that is our drain to source final test. Now we install the new MOSFET. MOSFET is replaced ready. Now we just put board in the casing and then we test the temperature of this DC side, how it's stable in the cool temperature.